Hello, it's Cullen. As you can see, Cullen Hable. This is one of my beyond the basics of data analysis areas that I want to put together. I'm going to put together a range of videos that go way beyond, not way, but a little beyond the basic data analysis that I will teach in a business research methods course or a research for decision makers course type of thing. And so these are things largely, I didn't come up with them, but I have adapted them from the academic theory that I've sort of wallowed around in for the last 25 years. So I've adapted, in this case, I've adapted the duplication of purchase law and the techniques of duplication of purchase from Ehrenberg, Goodhart, and Collins, I think. Martin Collins did a lot of that. Anyway, that was about 1970s. It was duplication of purchase. The idea that when a person buys a brand, they also buy competing brands in that category. When people buy Nescafe, they also buy Maxwell House. And so that approach, when we see pick any data where we see people get to tick boxes, I drink tea, coffee, carbonated beverages, all of that sort of thing, we get to be able to see what sort of sharing people do across their choices. Okay, that's enough talking about it in basics. I like to put data in front of people, and so let's get on with that. Okay, I'll show you a screen, and that screen would be this. And here we are. So here's a question, all right? What other type of beverages do you drink? I'm going to go back. This is live work that students have just collected recently. I'm doing this as a podcast, but also a bit of a favour to them. How can you make sense of this data? The basic making sense of this data is, out of, I think there's 260 responses there. Out of 260 responses, 200 said tea, and 150 said juice. And so you can get a regular count and what we would call penetration, I suppose. Tea has an 80% penetration. Juice has a 60% penetration. That's a way of doing it. You could do also, of all of the beverages that got ticks, you could do tea occupies a certain percentage. That could work. So there's all sorts of clever things, really Excel data analysis that you can do around this, and that's fine. That's what I would teach in a business research methods course. What I want to do is create a duplication table. Okay, so I want to look at, and it'll be better when we have data in front of us. I want to look at, of the percentage of people who ticked tea, how many also were drinking energy drink. I'd be saying bugger all, a few. But coffee's not showing here, and we'll talk about that in a moment. But of the percentage of people who said coffee, how many people also said they drink tea? And so that'll build a table of what we call duplication, and I'll take us through some of the fancy techniques that we can use just using Excel eventually to make sense of it. Before I get into crunching numbers or whatever, let's have a look forward. So we've done those pick any questions. Now, I'm sorry for, I'll have it in a non-sequential. I'll also apologise for continuity errors a little later on, but I'm sorry for the continuity errors. But when we've done those pick any responses, how can we use them? Wouldn't it be lovely if we could create this type of output? Imagine this: coffee, tea, and we look at this and we see that the percentage of buyers who, if we look at one of the earlier creations, the percentage of people who drank coffee, 72% of people who said they drank coffee also said they drank tea. 62% of people who said they drank coffee also drank alcoholic beverages. 40, 36, 27. When we go a little further, we say, all right, well, so the average duplication, where's the sharing going on? We find that lactose-free, people who say they use lactose-free, drink lactose-free drinks, huge amount of excessive sharing to tea. Now, as I, out of continuity, will say at the end, I think that's a bit to do with people getting confused between green tea and black English style tea. Never mind. But from such basic data, here's another one, energy drink. The people who say that they drink energy drink, 36% of the people who say they drink V, Red Bull, all of that, also say they drink Fanta, Coke, all of that sort of thing. And interestingly, the flip side of it is, come across the diagonal, 7% of people who say they drink soft drink also say they drink energy drink. Still in the right direction. It is a positive or symmetrical sharing. But look at this, alcoholic beverages. An excess of 4% of people say that who say they drink alcohol. An excess of 4 also say they drink coffee, but it doesn't share the same way. People who drink alcohol or people who drink coffee do not necessarily, like actually quite lower than average duplication into I drink alcohol. So, you know, my outtake here is that alcohol drinkers are a good target for the coffee industry, whereas coffee drinkers are not really a good target for the alcohol industry. Anyway, what follows from here is a process of how we end up creating a duplication deviations, a duplication table from data that looks like that. Tick, 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 tick. Person's finished that in like 11 seconds, and we end up with output that goes ahead and does that. I'll get on with it right now. So when we look at this, now you'll see that coffee isn't in there, and it's one of the things about the structuring of this survey that it was up here that the students said, the team had asked, how often do you drink coffee? Every day, a few times a week, all of that. I'm an everyday guy. But there is also, I don't drink coffee. You can see how out of this question A6, we can extract the people who do drink coffee, okay? Anyone who ticks 1, 2, 3, or 4 for question A6 is a yes for I drink coffee. And if there happen to be a 5 for A6, they're a no for I drink coffee. And that'll be useful when I go on and have to build the data set. Many of us use Excel. Excel is a great tool. I've got to say, to do a lot of the beyond basic data analysis, we want to use something a little more clever. And IBM have a software package called Statistical Package for the Social Sciences, and you can get it on a 14-day free trial. So if you actually need to do this work, get it on a trial and do it, because the licenses are bloody expensive. All right, so get it on a free trial and do this basic number crunching. So we end up doing a few things we need to do here. We need to export the data into SPSS. We need to order the data in the order of how many ticks there were in each box. We need to create that share table. We need to then go on from the share table, turn that into percentages, and then turn it into deviations. Let me just roll with you on this, okay? Okay, first thing to do, export to SPSS. So let's get on that. Just do a bit of my housekeeping. Let's get on that and export to SPSS. Actually, before I do that, let's just have a look at what these question outputs were, okay? A6, how often do you drink coffee? we ended up getting, out of the total 252 that we had, we ended up getting a count of 35 people said, I don't drink coffee. So we ended up getting, what's that, about 217 or something of people who ticked yes for coffee by default, all right? So that happens. We go on, we don't want locations, what we want is beverages. And so we also have the output straight out of Qualtrics. We also have the output where we have tea was 185, juice was 111, soft drink was 99, energy drink was 22. So that's a useful output straight out of Qualtrics. How cool is that? Useful output. And you can do, you know, if you're a good Excel data analyst, you'll be able to say penetration. That is, you know, 185 of the 255, about a 70%, 80% penetration. Juice, 111 out of 250, probably about a 40% penetration. Cool. You could probably create averages and pie charts and bar charts. What we want is, hey, of the people who ticked tea, the 185, what percentage of those also ticked juice? And that'll give us an idea of the sharing, and it's the sharing that matters. So cool, that is a useful thing, and I need to come back to that, actually, to be honest. I wish I had a screenshot of it, but I haven't. I'm going to pause on my recording and take care of that. One moment. Great, so that's what we're looking at. I just opened a duplicate screen. So we have the raw numbers, and they're very important for us. And so we have that sitting there. What we want now is to export this to SPSS, and that's fantastic. I'm going to go straight to data and analysis in Qualtrics. Fantastic. Data and analysis, there's our recorded responses, 260, fantastic. Ooh, somebody I think's doing something in background. Somebody's doing something in background. Well, I think my students are working on their data. Anyway, get on with it, Cullen, get on with it. Sorry about that, Alan. Cool. What I want to do here is export the data, and so in that point, import and export data, export as SPSS. Simple as that. No problems. And then hit the download button, and it'll go. Here's one I prepared earlier, and there's the one I prepared earlier. Fantastic. So we have the A6, and that is how often do you drink coffee, and we have the A1, 2, 3, 4, 5, 6, 7, which is do you drink other stuff? Okay, what we have here is this person drinks everything, man. They're into it. This person drinks first, second, third, the fifth, sixth, and seventh. This person, next person on the data set, drinks tea and juice, and not that, no, just tea and juice. This person's a tea and juice. So what we want to do is we want to see that, and A6 is what's buried as coffee. So I just need to create an A1_0.0, and I'll come back to you once I've done that, okay? We can see that buried in here in A6, how often do you drink coffee? Every day. And I just need to recode a new variable that is every day, a few times a week, a few times a month, a few times a year. Recode those as a 1, and then the I don't drink coffee. So bear with me. I'll go ahead and do that. I'll see you in a moment. And so there, through the magic of television, it's not so magic because it's a bit untidy, but through the magic of television, I have a variable for coffee, tea, juice, soft drink, energy drink, all of that, no problems. I'm going to do just a quick, I did a frequencies for coffee, nothing that you really need to, or that we need to talk about, but I found out there were 225 coffee drinkers, right? that's a bit important to us, because what we want to do is we want to order these variables in the order of how many mentions they got. So 225. And let's hit that button. And coffee was 225. So coffee gets lead position. If we have some continuity issues, then please bear with me. This is where we count the order of these. We can see that coffee has a lot. We already ran a frequency on coffee, and we found that there were 225. 225 out of the 260 respondents said coffee. What we want to do now is run a frequency on everything. Okay, so on everything, we want to run a frequency, and so that's pretty straightforward. Analyze descriptive statistics frequencies. We're going to get a count. Oh, look, they were already in there, but just for the benefit. Coffee, tea, those are all the things, whether we've got ones or noughts ticked. Okay, and remember that the ones or noughts, as we look at it, that's exactly what we have here. Coffee hanging over, and a 1. This person drank coffee. This person drank tea. This person drinks bloody everything. But down here, this person, they're a 1, so they tick they're a juice and a soft drink and a milk and flavoured drink and alcoholic beverages person, but not coffee or tea. How interesting. So we've got that there, and we can run with it and so what we want to do is count how many ticked each one. We want to order these in the order of what they were. It's I think coffee and tea are the first 2, but we don't know what order. I think alcohol is going to go up the scale a bit. So anyway, let's do the analyze frequencies. And remember, this is one I prepared earlier, so I'm just going to take it out and show you what I do. Analyze descriptive statistics frequencies, and then highlight all of those, tick it across, and then hit OK. What that tells us in the output here, it tells us that coffee has 225, clear winner. Tea, 185. Juice, 100. And so this gets a bit like squinting at the numbers here, but juice is 111. Is there anything bigger than 111? Alcohol, 160. Alcohol, 160. So we move alcohol up ahead of juice, right? Behind tea, but alcohol behind tea and in front of juice. Alcohol behind tea and in front of juice. Let's go back to our output screen, and we're saying, okay, juice. Is there anything bigger than 110? Nope. Soft drink. Nope. Energy drink, milk and flavoured, nope. 69, but nope. Okay. And so we go through this process of elimination. So we know that we've got juice, soft drink. I look at this, milk and flavoured, juice, soft drink, milk and flavoured, juice, soft drink, milk and flavoured. Bring this across, and that is probably the pattern. Lactose. Milk and flavoured. Oh, lactose comes with 24, comes before energy, right? So lactose comes before energy. Sweet. Right, there we are. There are our variables ordered in the order of their frequency. So remember, now what we want to do as we look at this, we want to look at the pairings. We want to create a table of if the people who said coffee, this person would turn up as a person who said coffee and also said tea. And they turn up as a person who said coffee and also said our next one, which is alcoholic beverages. And then, so what we want to do is create a table. Without any further ado, I'm just going to press buttons on SPSS on this. What we need to do is to do multiple response analysis. And first of all, we need to define the variable sets. We need to define an X set for this and a Y set for this. So I'm just going to press the buttons. It's recorded, and you'll be able to follow as you like. Analyze, multiple response, define variable sets. We go down and we find our tea, coffee, all of that. Coffee, right down to energy drink. Highlight that. We want to count the value of 1 because 1 is the we said it was yes. X, add. So we've defined an X response set. We also, now we want to define a Y value of exactly these. I have Thomas Grazurko, an MBA student, to thank for this. Man, I was doing it really manual before then, and thank you, Thomas, for that work. It was great. So here we are with multiple response sets, X and Y, we've defined them. We want to cross, and so that's fine, we've closed that, we've defined it. Now what we want to do is cross tab them against each other, and here we go. Analyze, multiple response, cross tabs. Great. We have defined our multiple response sets, so we cross tab X with Y. And okay, and here it is. There's our total count for each of those. 225, 185, 160, 199, 60, 99, 69, 24, 22. Those are those numbers we just agonized over. Fine. And as we go down the diagonal, we can see, yes, those who picked coffee also picked coffee. No shit. Those who picked tea also picked tea. Yes, that's because that's the diagonal. That's going to be, I don't know, unity or something, isn't it? So 225, everybody who picked coffee also picked coffee. No problems, that's fine. But of the people who picked coffee, 161 picked tea. Of the people who picked coffee, 140 picked alcoholic beverages. Of the people who picked coffee, 91 picked juice. And that's the raw input for our really clever duplication of mention, duplication of usage, duplication of purchase, duplication table. So we used SPSS to do the grunt work here. And now what we need to do is take that out to our ever-friendly Excel, do a little bit of magic in Excel, okay? So that's what we're going to do. Okay, as I said, here's our raw data, our magic in the background. While you were away, or while I was paused, I opened up just a raw version of Excel, okay? So we've got our X, Y cross tab, fine. And that's where, remember, just a raw count. I'm going to copy that straight out of SPSS into my bare spreadsheet. Perfect. Hey, what's going on here? That's what I wanted, never mind. Okay, so what we have here is a really neat set of raw data. What I'm going to do is just take all of those totals there. I'm going to Control C, copy them across to here. And I actually really don't need that stuff. Bang, take that out of there. Total on the bottom, I really don't need that stuff. I'll tell you what is useful. Create a penetration score. That is, actually I might do that a little later. Yes, no, yes, penetration. Complete with spelling errors, and that penetration score is of the total 258, what percentage of people said yes? I'd already sort of said that might be a neat thing to do. So easy equals that divided by that. Put a dollar in front of it. Remember, it's beyond basic data analysis, so I'm not going to walk you through that. But there's our penetration. 87% of respondents said that that they drank coffee. 71 said that they drank tea, and there we go. So that's a neat little thing to keep in mind, and we will run with that a little later. So there's our raw data, 225, right? So that's our diagonal, no problems at all. So first thing to do is to express these as a percentage, isn't it? So we got penetration there. But of the 225 that said they drank coffee, what percentage said they drank tea? So my little trick here is to copy paste this whole bundle, this whole sector diagonally downwards. I don't even know where I learned this trick. Sure, I'm self-taught on this one. Copy it diagonally downwards where things get ugly, because I can't get rid of this bottom screen, this bottom tag. I'd like to move it if I could, but I can't. So I'm going to bring it to a usable area, hopefully. A workable, usable area. Anyway. Great. Me and Windows, great friends. Great friends, I promise you. Excellent. No, I don't think so. Me and Windows, the best of friends. All right, Cullen, you need to get on with the job. Okay, so there we are. There's our copied raw table down here. Okay, of course we've got the penetration problem, so I could quite easily just do that, and I will. Great, so that penetration number is saying the same story. Great, but what we really care about is we want to create a percentage here. So percentage of the total. So equals that coffee divided by the coffee. Boring, I know. Equals, find it back up here on the bottom left, equals the coffee score divided by the coffee total. And you all know Excel, so there we are, coffee divided by the coffee total, and then make it so that when we copy it across, it keeps that coffee total the same as it was, multiply it by 100, and hit the OK button. Sure, that 225 that was in that divided by the 225 comes 100, but where it gets cool is when we look at tea. 71% of the people who said they drank coffee also said they drank tea. And 62% of the people who said they drank coffee also said they drank alcoholic beverages. And so fairly straightforward job to bring it across here and bring it down. And before we know it, ding, 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 we end up with a table. And I'm going to take out those hundreds because they don't tell me anything, do they? 100, 100, 100, 100, 100, 100, 100, 100. So they don't tell me anything. But now, I've made an error. And I wonder what that is. And so we're back in the world of continuity errors, but sure, where I had gone across here and I copied all of those across, and we found out that tea had 72, and so the duplication of tea with coffee was 72, duplication of alcohol with coffee was 72. And I think it was here where I said, so drag it across, drag it down, and there's our genius. I'll go back at the edit phase. But we, at this point, have Also, we find that for tea, the coffee duplication was 87. So when you're a tea drinker, that of people who said they drink tea, 87% of people said they drank coffee. Sure, the tea duplication is 100% because that's a no-brainer. The tea duplication across to alcoholic was 68. So that's a useful thing. What to do down here, instead of just those totals at the bottom now, really useful for us to talk about the average duplication, leaving out the zero, leaving out the diagonal, because that 100, boring, right? So delete, 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 okay? So, all right, we're looking at that and we say, okay, the average duplication, whatever people are drinking, the average duplication is about, what, 82% or something, from tea across to coffee, and then alcoholic beverages across to coffee. So that's a really neat thing to do. So we do equals average. Remember, we're all Excel geniuses, aren't we? Equals average of that right up to there, including the missing value. All right, Excel's clever enough to know that the missing value is a missing value, and it won't use it in the average. All right, so 84, no problems. Just a self-check here. Great. We don't want zeros in there, and Excel is doing what it said it would. So there's the average. The average duplication of coffee is 84. So average duplication down here. And it will get really powerful in a moment. All right. So bear with me. Average duplication 84, and then across to here. Average duplication, and yeah, because it's based on penetration, we expect that the average duplication is going to tend to slide downwards as well, because this is the penetration amongst people. For instance, the coffee number here is the penetration amongst people who said they that they drink tea, 87. This is the penetration amongst people who said they drank alcohol, juice. All right, so we sort of expect that the number, the average duplication, is going to track with the average penetration. All good. Sure, you might need to meditate on that for a while, but it's there. And there we go. Okay, where do we go from here? What we really care about, to see what partitions exist, to see if people who drink energy drink are sharing more than expected with people who drink lactose-free drinks or whatever. To be able to do that, what we want to look at is the deviation from average that we have there, right? So so we want to see that, well, tea is a little above the 84. That's 87 minus 84. Alcohol and coffee is 4 above. Is there anything else interesting there? Milk. It looks a bit boring, doesn't it? That the deviations were no larger than 4 from the average. So let's go with that. So we need to do our little trick of creating a diagonal downwards column again, because this is percentage. This one here is percentage duplications. This is longer, way longer than I thought I would be going with. But there we go. Percentage duplications. Fine. Percentage duplications. I'm going to make that big and proud. Great. Now, what we want here, we want to create, with my little diagonal downwards trick, we want to create deviations from average. Doesn't matter that it's filled with a bunch of div noughts. I don't care that it's full of div noughts. what I care is this bottom line. I can take that out too. And what I want to do now is deviations, duplication deviations. That's what I want to create here. Duplication deviations. All right, so that's great. We've got duplication deviations, and all we're doing here is we are saying, all right, how much did the tea coffee deviation duplication deviate from the average? So my job to do here, start with the top of the diagonal, equals top of the diagonal minus down here, the average, fine. And I want to dollar it up, and we're all Excel geniuses, aren't we? So I've just dollared it up, and there we go. That number means not much because it's the top of the diagonal, but when we scroll down here, that's where the gold comes in. Remember how I said that the T duplication of 87 was 3 above the average duplication, which was 84. That's an artifact of it that's there. So when I go like this and I scoot across, cool. We got numbers, not really telling me much yet. The coffee and soft drink duplication, way lower than average, right? So minus 14, minus 55. Oh, minus 55, that's the juice number, isn't it? The juice percentage number. Right, let's take out the diagonal because it's boring. Diagonal, goodbye. All right, and here's for the magic. All right, what we've got penetration there. That's almost just, it's irrelevant to us now. What we want to look at here is that coffee and alcohol, way lower than average duplication. Coffee and juice, way lower than average duplication. All right, so I'm gonna do the magic, and that is I'm gonna highlight the data cell. This is our data cell that we care about, right? They're the deviations from average, right? So that's pretty cool. We've got all our babies there. It's going to be great. And the job now, highlight all of that and run conditional formatting, new rule, and then just go with the default rule, okay? And what we have here is we get it lit up like a Christmas tree. That the energy drink, soft drink duplication, 36. That's a 36% deviation from average. Okay, so energy drink, soft drink, people are super sharing those ones. Interestingly, when people say, so what we see, this is asymmetrical here. When people say that the energy drink, they say I drink energy drink, 36% of people who say they drink energy drink also say they drink soft drink. And that's okay. That's a picture. Another picture is is it reversed? Does the love that soft drink gets from energy drink buyers, is it reciprocated? When people say soft drink, I drink soft drink. Is there an equally high duplication? And so as I come down here, it's across the diagonal. We look across here. The soft drink. When people say soft drink, it's a positive deviation. So 7% deviation, and so there is a deviation in return. That is that 7% of the people who said that they drink soft drink, there's a deviation of 7% in the direction in favour of energy drink. So there is a sharing We call this a sharing between soft drink and energy drink. This is how, for 50 years or so, the schools of empirical generalizations have tended to look at this sort of data, and I totally think it's a pretty good thing. All right, there's a lot to be said here from looking at this. This is where our fishing trip, where our voyage of discovery begins. And so this is where we are. Okay, any minute now, my wife's going to come home with my 14-year-old son, and I'm going to lose my recording studio. But this is what gives us our background for, or our beginning for analysis. Look at this. I'm looking at, we looked at energy drink and soft drink sharing, no problems. Look at what else we're seeing here. Alcoholic beverages, there's a slightly higher than expected deviation there of higher than average deviation, where alcohol people drink coffee, but it doesn't go the other way. That coffee people lower than average deviation. If you want to draw up if you want to make the Christmas tree look a bit brighter, you might, for just the purposes of analysis, take out the largest one. If you just get on there and hit the delete button, bang, the Christmas tree changes, gives you a new picture. And maybe that's helpful to you. It highlights, wow, that's one I hadn't even seen. Milk and flavoured milk sharing off with juice. Yeah, that makes sense. Higher than average deviation and in both directions. So symmetrical, higher than average deviation. So this becomes your tool for investigation. And so a lot of what we end up doing is drawing these lines in here saying, hey, look, here's this crossover. Perhaps this is interesting. The milk and flavoured milk, lower than average deviation with tea and reciprocal. And so we say, wow, there's not much sharing there. But what shares higher than average with coffee? So as we look along this line with coffee, it actually shows that coffee, everything else shares lower than average with coffee. That coffee maybe is a standout on its own type of area. But another way of looking at it is where are the big share-offs with coffee? So look, if we're thinking about trying to find new other users of coffee, then our worst set of new customers are likely to be lactose-free drink users. And then a bit so-so with juice and soft drink and energy drink, a little bit so-so. And our greatest opportunities for getting new coffee consumption, category level coffee consumption is from drinkers of alcohol, drinkers of milk and flavoured milk. That's it, and tea. And look, in its obvious instance, that's a bit of a so what result. But what I've been able to show you is from, just allow me to, thank you for that, IBM. But what I've been able to do is to go from, what I've been able to do is to go from this data, which is just nice bar charts, and into, I'll just go back and look at the survey because that's helpful for us to remember what the data looked like. So to go from just bar charts like that, and from data that looks like this, you know, tick, 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 really low energy activity for the respondent, for us to be able to go from data that looks like this, how often do you drink coffee and what other beverages do you drink, and to be able to come in and take that fairly basic data and draw it into a duplication table that tells us lactose-free drinkers, no chance are they going. Well, yes, definitely they're big for tea, and I think there's a bit of a split there. Going off on my own thing, you know, green tea versus black tea. You know, classical English type black tea, milk and sugar versus green tea. I think there's a bit of noise in the data there, but from that very basic data here, we want to know about improving coffee category level consumption. We go, I'll tell you what, we sure as hell won't be going after lactose-free drinkers and juice and soft drink and energy drink users. You know, just potentially there was the whole energy drink, coffee is just another energy drink. That's good. Well, no, energy drink is not bringing it across. Your best comes from, strangely enough, tea and flavoured milk drinkers, your best category level consumption, maybe to go after tea drinkers and flavoured milk drinkers. So there we are, out of basic data where we just ask people to tick boxes, go through, export it, use a piece of software that you can get a trial account for, SPSS, create a base level output using the technique I showed you, and then end up with a piece of analysis that looks like that, is what I would call probably one of the best yields that you can get in market research. I like it. When I find that I don't get people to use, when people are saying, you know, my survey is getting too long, I say, well, stop using 7-point scales and use pick any scales, just as we had there, multiple tick boxes, because I've got a technique you can use to draw life into the data. When we look at it, it's a powerful technique and it's here for you to use. With all that said, Cullen might tick a box, look into the screen. With all that said, that was one of our Beyond Basic Data Analysis modules, and I see that it's probably pretty handy. Hope it works for you.